Welcome back. Today we're going to continue on our journey of section 5.1, and we're going to look at some more complex equations, looking at that 2-to-1 ratio and exponential, solving for those exponential variables, or the variables in the exponents. So if we look here in our problem that I have set up for us, remember we want to have a common base, and if we have that common base, then we're going to look at those exponents. And notice today we don't have that 2-to-1 ratio. Remember, we want this exponent to be twice as much as this exponent over here. And if I take this x here and I multiply it by 2, I end up with a 2x, don't I? I have 2x plus 1. So what I've got to do is I've got to clean this up so that I can get this down to just 2x. So what I can do with that 2x plus 1 is I can break this apart. Remember, when we have a common base and we multiply, so if I gave you maybe x squared times x to the third, we said that that was equal to x squared plus 3, or that 2 plus 3, which gave us x to the fifth. Well, the same thing's going to happen when we have a numeric or a constant or a numeric value for our base. So we can take that 5 to the 2x plus 1 and make it 5 to the 2x times 5 to the first. And what that's going to do is it's going to separate kind of these exponents. It's going to allow me to get to that 2x. And some of these it's going to take a little bit of time to play around with in order to get them down to that 2-to-1 ratio. So you may not get it on your first time, which is fine. Stick with it, play around with it, and have some fun with it, and get down to that 2-to-1 ratio. But always look at your exponents to see what do you need to multiply this, or multiply this one by 2 to see if you can get somewhere in here. And it may be that you have to manipulate the middle one here, the second exponent here, in order to get it to be half of the first one. So we'll see a couple different things happen today. So now what I can do is I can write this as 5 times 5 to the 2x, or I can put my 1 there if I want, minus 126 times 5 to the x plus 25 equals 0. Now I have that 2-to-1 ratio, and now it becomes a problem that I saw just yesterday. So I can come off to the side and let my 5 to the x be my y value, and 5 to the 2x be my y squared. So I've got then 5y squared minus 126y plus 25 equals 0 when I do that substitution. Remember, this y and y squared, it's arbitrary. We could let this be any variable we want, but it allows us to get into a form that we know something about. We know how to solve this equation because now it's in a quadratic form. So we're going to go ahead and factor this. So we have minus there, minus 25 minus 1 equal to 0. Again, just like yesterday, we're going to go ahead and solve for y. So y is going to equal 1/5 here, and the second one, y is going to equal 25. We know that the y equals 5 to the x, and we're solving for what x is. So we're going to replace that 5 to the x with our y. So we have 5 to the x equals 1/5, and 5 to the x equals 25. Go ahead and find a common base, which is going to be 5. So 5 to the x equals 5 to the negative first. And here, 5 to the x equals 5 squared. So x has to equal a negative 1, and over here, x has to equal 2. And that solves that exponential equation. We're going to go through several of them here today, and you can see different things than I see, which is quite fine. It's just getting down to something that we can solve. So here, notice again we have a common base, so that's 2. If I look at my exponents though, x plus 2, if I were to multiply that by 2, I would get 2x plus 4, wouldn't I? Well, I have 2x plus 3. That's a problem. And if I take 2x plus 3 and I divide it by 2, I'm not going to get down anywhere close to x plus 2. So what I have to do with this one is play around with both of my exponents. Think about 2x plus 3. If I were to divide that by 2, that 3 would become a fraction. That's kind of ugly. So what I'm going to do is maybe I'm going to make this 2x plus 2 plus 1. So notice this 2x plus 2 is kind of going to be now my new exponent of 2, and I'm going to split this 1 off. Because I can take 2x plus 2 and divide it by 2 and get x plus 1. So 2x plus 2 divided by 2 is x plus 1. I can make this x plus 2 into an x plus 1 plus 1. So what's that going to look like? Well, I'm going to break this into 2 to the first times 2 to the 2x plus 2. So notice again, I can add those two exponents together, and I still end up with 2x plus 3. So I'm not changing the meaning of this first term. I'm just changing what it looks like. And over here, I'm going to change this 2 to the x plus 2 into a 2 to the first times 2 to the x plus 1. Again, notice if I add these two exponents together, 1 plus x plus 1, I get x plus 2. So I'm just changing the look of this second term. Plus 4 equals 0. So what that's going to allow me to do then, 2 to the first, well, we have 2. 3 times 2 to the first, that gives us a negative 6 there. More importantly, if I let my y value, my arbitrary y, equal the exponent of my middle term there, again, x plus 1, then y squared is going to equal, 2 to the x plus 1. Then y squared is going to equal 2 to the 2x plus 2. So my problem becomes 2y minus 6, or 2y squared, minus 6y plus 4 is going to equal 0. I can go ahead and factor out a 2, and it becomes just like we saw yesterday. Minus 3y plus 2 is going to equal 0. I'm going to go ahead and factor that. So I get y minus 2 and y minus 1 equal to 0. Again, I'm going to solve for y, so y equals 2 and y equals 1. But I know that y equals 2 to the x plus 1. So 2 to the x plus 1 is going to equal 2 from our first part. I'm going to make some space over here, I guess. 2 to the x plus 1 is also going to equal 1. Getting ahead of myself. Is going to equal 1 from the second part. So I'm going to go ahead and set this equal. My exponent's equal, so I have x plus 1 equals 1. And x is going to equal 0. Over here, I have a base of 1. I want a base of 2, so my common base is going to be 2. 2 to what power is 1? 2 to what power? It is 0. So we're going to go ahead and set x plus 1 equal to 0. So x will equal negative 1. And those are going to be our two answers. In our last problem that we're going to look at today, we're going to notice that we don't have a 2 to 1, or we don't have a common base to start with, and we're not going to have a 2 to 1 ratio. So the first thing I'm going to do is get these bases to be the same. So what base do I know between 3 and 9? Well, I know 9 is 3 squared. So I can write this as 2 times 3 to the 4x plus 1 minus 5 times 3 squared to the x, which is going to be 3 to the 2x minus 1 equals 0. Now if I look at my exponents, I want that 2 to 1 ratio, so it's in a quadratic form. If I take 2x and multiply it by 2, I get 4x. So I need to peel this 1 off. And the way I'm going to do that is I'm going to write it as 3 to the first times 3 to the 4x. Again, if I bring these back together, my common bases, I add the exponents. 1 plus 4x gives me that 4x plus 1. So I'm not changing the meaning, I'm just changing the look of it. Minus 5 times 3 to the 2x minus 1 equals 0. I'm going to go ahead and come off to the side and do my substitution. Y is going to equal 3 to the 2x. Again, it's that middle term with that exponent. And then my y squared is going to equal 3 to the 4x. So if I rewrite this in quadratic form, I get 6y squared minus 5y minus 1 equal to 0. Now I can go ahead and factor. Factorization of this, we get 3y. No, we don't. We get a 6y. And then we're going to have a y here. We need that negative 5, so we need a negative 6. And then we're going to get a positive 1 here. So that was a 6 there. So I'm going to have 6y plus 1 equal to 0, and y minus 1 equals 0. Here we get y equals a negative 1/6, and y equals 1. I'm going to replace my y with 3 to the 2x. So I have 3 to the 2x equals a negative 1/6. And I'm going to come over here to the side. 3 to the 2x equals 1. I'm going to go ahead and solve this one first. So 3 to the 2x is going to equal 3 to the 0 again. Remember, if we have 1 as our base, we can change that base and take it to the 0 power. So 2x will equal 0, or x will equal 0. I'm saving this one for last because this one is a little more interesting. If we have 3 to the 2x equals negative 1/6, we don't have a common base that we were asked to for yesterday. So we can't make 1/6 into a base of 3. So what we're going to have to do here is think about 3 to an exponent. Think about 3 to 2x. Remember, an exponential is always going to be a positive value. We can never take 3 to an exponent and be equal to a negative value. So whenever we see something like this, we're going to see that we have no solution from that portion. If you don't like that, think about your logs that you did back in pre-calculus. If we take the log of both sides, the log of 3 to the 2x equals the log of negative 1/6. If we were to put that into the calculator, we can't take the log, again, of a negative value, because the domain of our logs is from 0 to infinity exclusive. So we know, again, that we would run into trouble from that one. And we'll talk about logs a little later on, but there's just kind of a little preview, again, of where we're headed with that. But for now, if you get an exponential equal to a negative value, we know there's not going to be any solution there. So the only value we get out is going to be 0. So to recap just quickly there today, we're going to make sure that we have that common base. Oh, I guess we can look at that common base here. Notice down here we didn't have that common base, so we had to make a common base. And we want to get that 2 to 1 ratio by either working with the middle one or the first one or both of them. So if you have questions, let me know. Good luck, enjoy, and have fun with it.